sticking to it. Okay, cool. There we link it. Okay, cool. 33, search in rotated sorted array. Suppose an array is sorted in ascending order. I'm saying that weird. Suppose an array sorted in ascending order is rotated at some period unknown to you beforehand. You're given a target while you search. If found in the array, return its index. Otherwise, return -1. You may assume no duplicate. Okay. So this seems like just a general or we'll go off the, I wouldn't say the base case, but like, the textbook kind of problem for this is just like you have a sorted array and then you would binary search, right? So I think that part is more standard, but now in this case it's a little tricky, you could say, because there's a period. Okay. So I think that I have two dots that come right into mind. One is, I mean, it should clearly, especially because they give you the complexity, like it should still be binary search to some degree, or some, maybe not binary search but like divide and conquer type solution. Because clearly if you just go through the array and it's all n, then it's not going to, like, one is there's no point to this form and it shouldn't be a number, etc. So I assume it's something like that, some kind of divide and conquer binary search thing. The second thought that comes to my mind is, well, can we do this in one binary search, or do we need to know the period and then do a binary search off that way? Which maybe is similar in that, like, well, once you know the period, then you could just do some offset shift type thing, right? And then that's actually a way, that's just a binary search as well. Which, while, I mean, like, then that's a known solution, even though, coding may be a little tricky. But for now, we focus on algorithm. And how would you find the period? Okay, I think actually, my initial thought was some weird thing, which not all my initial thoughts are right, so I'm just kind of trying to articulate all my thoughts as they come in ways that and but first thing I would think about is like maybe two adjacent values, and maybe we eventually get to the one where the number is greater than its following neighbor, right? But I think the other way that I was thinking about it is that, if you look at the first index, that's good enough to use as a comparison for the period, and then you could binary search for that, right? Because if the number is bigger than it, or like, so let's say you're using the number 4, and maybe instead of using that, let me just type it out a little, so maybe it's easier to visualize. But let's say you have this array, and now you're comparing every number to 4, right? Well, let's say now you test 7. Well, 7 is bigger than 4, so now you want the left half. So now you want 4, 5, 6, 7. Wait, or maybe the other half, sorry. Because it's bigger, you know that if a number, or that if there's a period, then it would have to come afterwards, right? Because there's a number smaller and average. So then you 1 and 2. And then let's say your next number is 1 to test to see if it's a period. Well, 1 is smaller than 4, so that means it has to be between the 7 and the 1, and so forth, right? Is that kind of, hopefully that definitely if y'all have questions while I'm kind of half explaining this, I can solve it, but I could try to answer it. But I think that's going to be my way to figure out the period. And as I said before, once we have the period, then it's just a standard-ish binary search. I mean, maybe you have to, do some offset manipulation just to make sure your edge cases are right. But otherwise, it's just a binary search, right? So, cool. So I think that's all I need to kind of start coding. Definitely while I'm coding, let me know if y'all have any questions, because I mean, maybe it'll come up while I'm coding, maybe not, I don't know. And one thing I would say is that I actually implement my binary search in a non-standard way, I would say. And you'll see this later, but I actually learned this trick from a buddy of mine, which still is log n plus some additional constant, but it's more right than it's more guaranteed to be correct. Just that it does a couple more operations. You'll see it when I kind of code it out. Cool. Okay, so let's get back to this problem. So I do want to, so I want to find a pivot in the way that we just said. So I mean, I guess we don't have to declare next first element explicitly, but let's do it anyway. Just see what happens. Can n be 0? Target is 0. Yeah, okay. I mean, I guess. Oh, I feel like some of these farms always have like these weird cases, and then like I'm like, oh man, I should have known better, but I didn't. So now, but now I've now I'm gonna do that instead. But cool. Okay. So now we binary search, and there are a couple of ways to do it. I just go left and right nowadays. Left is equal to 0. Here is equal to length of the array, maybe -1. It shouldn't matter, maybe. So while left is right, let's just do +10. And I'll explain kind of where the +10 comes from in a little bit. So okay, width is equal to 2, and then if width is greater than first element, what did we say? If the middle is bigger, that means the pivot point is afterwards, if it exists. I think there may be a, yeah, I think maybe there's a check. I think, yeah, I mean, yeah, if the entire array is already sorted, maybe we could add a check to that, which is not that hard. You just check the last element and the first element. But maybe I'll do that later. I don't know. Maybe I'll actually put this in a helper. Because this is going to get a bit wordy. And then now I can just put it here. If nums say 0 is smaller than the last element, then we return 0 as the pivot, maybe something like that. We could play around this afterwards. Oh, I guess I should finish this function first. So anyway, going back. If the middle is bigger than the first element, then we want the right, so that means we want the left to be mid. Okay. Else, did I miss something? Why is this? The right equals mid. Okay. And the reason why I do this is that now I just want a for loop for x in x from left to right. In this case, I actually don't need the +1 because I'm checking the +1 offset, which you see a second. If nums x is greater than nums x +1, then we return x maybe. Yeah, that should be okay. And this should guarantee to be true unless of this case, I think. So it should be okay. But why is this in red? Oh, maybe I had an extra space I didn't see. For now, I'm going to return -1 and also just maybe put why are you here? This is just a placeholder. In real code I would throw an exception or something like that. Cool. So I think that's how you find the pivot. Okay. And now let's just print out the pivot as an example. How do I add another one? Let's do 2 of them at the same time, because I'm greedy. Or paralyze some process. Oh, did I do length? It's just typo then. Oh, what am I thinking? Okay, so the period is 3, which is 7. Maybe I want this +1 then. Oh yeah, because I should return the first number that, yeah, I wonder if that would be the case if it's at 0. I might have to run some edge cases stuff on it. I mean, that's not so bad though. Yeah, so we want the what we call the period. Though maybe I need a better name for this. I mean, that's what the vocabulary they use, but because when we're going to do binary search, it's going to be a little confusing. But maybe it's find offset. Maybe that's a better name, but okay, it's fine for now. I think one more thing what did I click on? Okay, one more thing I want to test. So right now I'm just testing this function, and also one thing that if I was while I'm coding this, and let's say I'm in an interview, what I would say is that in theory I would write a unit test and kind of write the expected values here and stuff like that. I mean, right now it's all in my head, so I mean I know what the expected values are, but or what. But I just want to see what the period would be. The period? That's a period. A period. Anyway, but yeah. Because the second part is trivial, but I want to, and actually, I mean, that's why, I mean, it's also a good thing to bring up when I'm in an interview. That I would do is I modularize this code so then I could test this code independently from the later code, which is also to use this in kind of like a TDD kind of way. But, you know, oh, there's a, see, that's good, I guess. Where else did I print stuff? Oh, that is where I print stuff. Okay. Oh, I put in too much stuff that I forgot which way is, but yeah, I think the value here is for this one, but shouldn't this return 0 though? Well, let's double check that first. It could be that this one return value here, which is for one element, maybe that's fair. Oh, I didn't run the code. That's why nothing changed. Okay. Oh yeah. So that's for the second one. So, so yeah, maybe yeah. Okay. Maybe I'll just special case the one element thing just to make things slightly easier. And so that should be okay. I think it should work on the other cases. At least it doesn't complain. Why did I get that 2 prints? Oh no, that's just the output, which we don't return anything. Okay. So I think that's just right-ish. I mean, those are the edge cases that I worried about. I mean, the other ones I guess the only other one that actually I wanted to do, but then I forgot is maybe this is the last element just to make sure. So that should return 7 or something like that. Oh, 6 maybe. Yeah, 6 because it's the 7th element. Okay, cool. Okay, so now I'm convinced that the find period thing is mostly right. Yeah, so then now we use this to you know, search. Maybe in the spirit of marginalizing it, I guess I'll just write another thing here. An offset or something. Okay, and yeah. So left 0, 0, right? I'll just do. Actually, maybe we start from. No, we could just do this. I mean, we'll just do it on every thing. Maybe -1. And then we do the same thing again, but this time we kind of I think we talked about that there are multiple ways to kind of think about this. So what? Oh, if the middle number is actually it's this plus the offset, I think. Well, I mean, I guess we could do it on the check. Yeah, actually, let's do it on the check so that is because I think otherwise it'll be confusing. If nums, let's do size is equal to, so I guess it's a len, but so if this mod size is greater than target, then that means we want the left half, which means we move the right to mid. Okay. And then we do the same thing here with X range. I always prefer X range. think all the Python people would love it a little bit too. Is it X? Yeah. Okay. Oops. Target and then pivot. Maybe that term is a little weird, but why did I return 3 things? Oh, there are 3 columns. Okay. I guess this didn't return then. So maybe there's an off. Oh, yeah, and this. So there's the reason why I didn't have a +1 here is because of this x +1, but I forgot to put it here. But I hope that's right anyway. Okay, so now I got the right answer. I think one thing there are no duplicate entries. I think what I want is also a bigger array, because I kind of cheated here in that because of the left +10 thing. Yeah, well, this is never true in our tests, so so we should kind of test our assumptions. Actually, should have done it earlier as well, but and in this case, it's actually what you call it? Okay. And now let's try another one. Let me do a couple. And the reason why I'm testing a lot in this case is just because I think for me anyway, there's a lot of potential for off by ones. Like even this X actually. No, that should be okay. It's a little weird, maybe. Okay, so there is a weird. I think there's something weirdness that I probably missed. Oh, that could go. That's why I was doing this because I don't use the offset here is why. So okay, that's what I thought. Because I thought I missed something weird, but okay, try again. It's just that I got lucky then in the previous cases. Oh, well, that's not great. Maybe I need to return this plus to. Oh yeah. Oh yeah, because this goes so actually we want this number. Okay, maybe. That's why we are testing. Okay. Whew. Am I confident now? Yeah, I mean, kind of, but let's try a couple more. Just do the last 2 then. Okay. Yeah, let's submit. Oh, I guess I could have also thrown an exception after this, maybe. Oh, no, because, yeah, for that happened. But I forgot about the not existing case, so so that's actually shouldn't be an exception. It just doesn't exist. Yeah, okay. Well, whoops. I thought about it too, but silly mistakes. But at the end of the day, you gotta own your silly mistakes. Also take this opportunity to add a couple more testing then. Yeah, okay. Sad. Oh, no. Wait. Oh, so this does fail in an exceptional way. So I thought that this may be a thing if this is on the edge of right and right +1, so maybe this should have a right +1, but then it may go out of bounds. Like I said, my weakness is off by ones. That's why I kind of test this a lot. A lot of numbers actually. Let me just put it in here. I guess I don't need the other ones. Excuse me. I know what it. Okay. Let's do it maybe. Because it was putting this, it's just not finding the period. Why is that the case? Because it's on the first element. Okay, I did thought maybe that's a thing. Would this give me an outbound? Let's see, French reverb got unlucky. That's because of this requiring both. It'll work for this one maybe. Oh man, not even. Because the period's 113, and what we need is this to compare one element 112 to 113. Off by ones. H. I guess I could do something like this, but it's a little awkward. That's not right. Well, let's see if it works for us. Even if we'll worry about if it's awkward later. Man, why is that happening? Why is this not? Oh. Wait a second. Oh, maybe I have a typo here somewhere. That doesn't make sense. What I was going on doesn't make sense. The period is not between 113. I mean, that's where the number 30 is, but did I get this wrong? Okay, double check. If middle is, okay, check the middle. If it's bigger than the first element, we do want the right side. That's right. And we don't change the, should be right. And why is the period all the way down here? Why is it looking at 113 to 121 then? Okay, so I was debugging the wrong thing actually. First, okay, let's just print the mid, maybe, and it's gonna. Maybe try putting the first element. Yeah, it was. Oh man, am I just being dumb? Okay. Okay, this should be S submit. Huh. How did that even pass so many test cases? Okay. Well, oh, I didn't. Oh, num submit. Where did the S come from? Did I? Was that from the last poem? I think that's from the last poem. But Okay. So, wow. I mean, I'm surprised that you even got anything right. The reason we got it right is because these numbers are approximately the same as like, so num sub I is roughly I, so that's probably why it's been right. But this one, this input had more gap. Wow, what? I mean, it's a silly typo, I guess, or whatever. But it's still a little sad. All right, I'll just submit this. Yeah, okay. So I mean, okay. So I actually didn't. I think that's sometimes you overcompensate a little bit for your off by ones because like I was saying, like I was worried about being off by one in weird places, but it turns out that, yeah, I just actually was not comparing to the right thing at all. So I think the reason is because, and some of that is unintentional. I mean, I don't think even it's laziness. It's just that I kind of, I don't know, copy and paste the problems, but because all these numbers are small enough that they're roughly num sub I is equal to I. So like, I mean, it's off by one in some of the later numbers, but that's why it worked because the ith index is I, or like num sub I contain I. So in a way, like they're equivalent. But I mean, yeah, sometimes I mean, I don't know if you want to say I got lucky because it was the wrong solution, but I mean, in an interview, they'll either help you or kind of guide you through it. I think it's in general, like when you're interactive with someone and they know what they're looking for and you describe the problems correctly, sometimes you just a brain fart. So it's okay, but still, yeah, like sometimes you get quote unquote lucky and that it passed all the test cases and it's right, but you have to be able to prove yourself wrong, which I don't know. Sometimes it happens still, but that's why you have unit testing and all that stuff in your production environment, right? Especially for stuff that's very unit testable, like these things. Okay, cool. I would say, yeah. I mean, thank you, yeah, JJ9897 for asking this problem. I think this is a I don't think I've seen. To be frank, I think I probably have seen this or variations of this in a while, like a long time ago. I don't think I've seen it in a while. So I mean, like we went over our or my thought process as I kind of got through this problem. I think in general, I mean, and I would say I love binary search problems to be honest because it kind of forces you to kind of think about things in a like first you have a big problem and then you kind of think about it in half the size and so forth. So I love binary search problems. So, but I think this is like there's only one kind of trick that you have to think about. Otherwise, it becomes a standard binary search problem, which is the kind of defining the offset or what they call period or so forth, or the rotational period. So I think that's probably fair game because I think in a sense that if I'm an interviewer and I see that you're struggling, I would give you one hint, or there are a couple of hints I could give you, and then eventually just tell you how to kind of find this period or offset or whatever, and then and then the rest you could see how the programming, how they how the interviewee and what their thought process is and how they program and so forth. So I think I dig this farm, and I think on a difficulty level, it's probably roughly like probably very correct for a phone screen. I think this fits into probably like a 40-minute slot on average, I would say, because someone has to write binary search twice. But yeah, in terms of yeah, I mean, I think I'm pretty satisfied with this problem. I don't know if y'all have any more questions, but yeah, I mean, I think going over, I forgot to do the complexity analysis because sometimes I just take it as a given. I mean, I kind of allude to, at least for this problem in the beginning, because they also tell you that what your one-time complexity must be. But it's just, yeah, on each query is log n. And I don't allocate extra spaces other than like constant size. Yeah, so, oh yeah, what's my unique? So I do this thing where instead of, because I think the standard way, if you will, is left is less than right, I think is how most people do it. And the answer is in left or sometimes right. That's why, but then you have to do like all these, depending on the problem, sometimes like you get off by once a lot. And I mean, as you guys see me here, like I worry excessively about off by once. So what I actually do is I terminate early, where it's less than 10. So this loop is only 10, maybe 11, depending on how the problem set up. So you only do an additional 10 or 11 if statements over one statement. So it doesn't change the overall complexity, but at least for like and it's usually right because this is just more, and you get the exact index that you want. In this case, is x, which is x plus 1, versus worrying about your binary search, like getting to an exact way. I usually use this technique. I mean, I don't do this for bisection stuff, meaning like numerical analysis type things where you want the answers to be a double. I usually only do this for like indexy stuff or integer-y stuff because in binary search, in binary search where the answer, or bisection where the answer is a full or a double, like it doesn't matter how many times you do it because like eventually it converges to like something that's like really small anyway, right? Like if you do, I don't know, say 60 iterations, you get the answer, and that's like more than double could precisely define the number anyway, right? But in this case, like it matters where like your index is sometimes off by one for whatever reason. So I do a for loop to kind of check which one of it inside that period is, and it's and that's how I write my binary search in general. And if forced to defend it, the way I also structure it is that that's how C++ has this thing where it actually isn't quick sort. It's in sorting, that is. It's not usually quick sort. It's something called intro sort or introspective sort. And what happens there is it does sorting. So if you I don't know, taken an algorithm type class or maybe even an intro CS class, I think they probably go over sorting. You know that they always talk about quick sort, the worst case complexity is n square, and rarely it happens because you could just randomize the input and so forth. So like it'd be very hard to give an input that kind of forces n square, but it still happens in the real world, right? So what happens is that they limit it by the stack depth of quicksort, so that after a certain, like let's say you have n elements, after you do log of n recursions, it actually switches to heap sort on those on the sub chunk, if you will, and that guarantees an n log n no matter what, even though heap sort has a has a higher constant for overhead, but it guarantees n log n, right? So because you can't degenerate any faster. And actually, it does an additional thing where if n is small enough, it actually changes into something that's, I always forget. I think selection sort or I think selection sorts for the least swaps, but one of the n square sorts, I might have forget which one. Either selection or insertion, but one of those sorts, because for n where n is very small, it actually fits in. It all fits in memory, like a very low level cache of memory, and then even though it's n squared, because everything is already in memory, it actually does things way faster than like you don't have to go to the disk to fetch things in the memory and so forth. So there are a lot of like things like that. So anyway, that's a really long rounded way of me saying when I do something like this, in theory, it limits the worst case scenario, and at least for me, the thing that I like most is that you're never off by one because not never, but like you're never off by one because of your binary search. You're off by one for other reasons, because I don't know. And it's not unique to me per se. I did learn this trick from someone whom I don't remember who I learned this from, so I can't give credit. Sorry if you're watching or whatever. I don't know. This reaches you out in the world, but it is something that I learned, that I was like, that's a really cool way to make sure I don't have weird. Because that, like, if you write a lot of binary search, with like indices, like I don't know, maybe it's a problem unique to me, and this person who might copy this from, but like I always have like weird off by ones where like sometimes the left or the mid checks for the wrong index, and then I don't know, right? So it goes to truncate like a little bit on the edge, or like you have an element that's on an edge, and then what happens? And there's a lot of like weird things like that when it comes to like things that are discrete, that I run into a lot, and I find that this is this is a solution that I find it easier to deal with. And obviously, if you and this is just like for programming to a bot, but if I'm you still have to be able to articulate why you're doing this if you're in an interview, so that both the practical reason, but also maybe the theoretical reasons and so forth. Cool. I think that's all I have about this forum. Hopefully that's enough. Kind of went on a little bit sidetracked, but thanks for asking about binary search. I think that's something that I think not that many people know about the way I do it, but something that is kind of useful. That said, that's only if you're forced to implement binary search. I think nowadays, both in I mean, maybe in this case I do. I don't know. But like both in C++ and Python and probably even other languages, I just don't know all of them. But they have some sort of binary search on an array type thing, and all you have to do is give them the comparator function, right? So or like something like that, and it assumes certain things. But yeah, so you may not need to, but when I find that I need to, that's what I do.